Greetings, geometry students. I appreciate you finding time to get your notes taken care of. Today we're going to switch gears a little bit, stop talking so much about angles and arcs, and instead focusing on lengths of lines in circles. Copy down your title as well as your objective. And our objective for the day is the student will discover the lengths of various line segments that interact with circles. Now I realize you're getting a rather large pile of formulas piled on you, and fear not, it's getting near the end. So the list of formulas is getting smaller. This is actually going to be the last lesson where we're going to spend time looking at angles and line segments and things like that. However, we'll still have one more lesson to look at, and that will be areas and circumferences and things like that. As always, press pause anytime you need more time to copy something down, and then hit play when you're ready to move on. Okay, there are 4 rules that we're looking at today, dealing with our tangents and secants and chords intersecting each other in and around our circles. So let's begin. The first rule that we're going to look at is when 2 tangents originate from a common endpoint. Now, this is actually a rule that we already talked about, but it fits in 2 different places in our discussion. Okay, and here is the situation. We have 2 tangents, line segment AB, and another tangent, line segment BC. They originate from a common endpoint B, and we've already seen this formula before, and the rule says that if 2 tangents come from a common endpoint, then the lengths of those tangents are congruent. Okay, so that one should be familiar to you, but go ahead and copy it down again anyway, just to make sure that we got it. The next rule that we're looking at, a little bit harder to deal with. In fact, a lot of people find this to be one of the more complicated rules in all of circles, and this one is when a tangent and a secant originate from a common endpoint. Now, we've already seen this situation before, but we saw it when we were talking about the measurements of the arcs and the angles that were caught in between the tangent and the secant. But today we're talking about the lengths of the segments that are connecting all these pieces. Now, please notice that the tangent is in one piece from point F to point E. However, the secant is subdivided into the length from F to G, as well as the length from G to H. All 3 of these measurements are going to be important, and here's how they are structured. Okay, the basic rule here is that the length of the tangent, if you square it, that will equal the product of the length from F to G, which is the secant outside of the circle, times the length from F to H, which is the length of the entire secant. Okay, so pay special attention to the way the secant is being treated there. It is not the 2 different pieces of the segment, or the secant, because actually the length from F to G gets counted twice. It gets that first term from F to G, so that length will be counted, but then the thing it multiplies by is the entire length from the common endpoint F all the way through the circle to the back side of the circle at point H. Okay, people have a little bit of trouble with this one, getting this one memorized and applying it correctly. So let's make sure we pay special attention, take good care when we're using this formula. That way we won't mess it up. Okay, our third rule of the day is dealing with 2 secants coming from a common endpoint. Okay, and again, we have seen this situation, but we saw it from the standpoint of the arcs and the angles between all of these lines. Okay, but today we're talking about the lengths of the lines. Okay. Now this formula looks pretty bad, but it's actually treated pretty much the same way as the secant was treated on the last example. Okay, please note you've got the length from K to J, which is that top secant outside the circle. He is going to multiply by K to I, which is the overall length of the exact same secant. When you multiply those together, that should equal the length from K to L, which is the length of the bottom secant outside of the circle, times K to M, which is the entire length of the bottom secant. So in short, or in plain English, basically this formula says the length outside of one secant, or outside of the circle from one secant, times the entire secant should equal the length outside the circle of the other secant times the length of that other secant. Okay, difficult little rule there, sometimes very easy to plug in incorrectly, so just pay close attention when you're dealing with the lengths of secants. There is one more rule, one more situation that we have discussed, and that is when two chords intersect inside of a circle. Okay, and again, we have seen this situation before, but that was angles and arcs. This is the lengths of the secants. This one's a little bit easier to understand, pretty straightforward, and the rule basically states that if you take the two pieces of one secant and multiply them together, that should equal the two pieces from the other chord. I think I said that wrong a moment ago. The two pieces from one chord will multiply together to equal the two pieces from the other chord multiplied together. So A to E, E is the center point, E to C, multiply those, that should equal D to E times E to B. So that one's not too hard to understand. It's just a little rule. Probably needed to have it explained to us. It's not exactly common sense. We needed somebody to tell us that this is the way that that one would work. Okay, now I've got 4 examples that we're going to look at. I'm going to take you through the first 2, okay, and I'm going to ask you to do the final 2 on your own. Okay, and as always, what we're looking at is they're just going to bring us some type of a problem, and in this problem something will be going on, and they'll ask us to solve for some piece of missing information. It'll be up to us to decide what is in the picture, and then for us to choose the proper formula to go along with that situation. So in this particular case, the problem we're looking at, solve for x, it's up to us to identify that we have two secants from a common endpoint. Then it is up to us to know that if those secants come from a common endpoint, then the lengths to the points of tangency will be congruent. So this length here will be congruent to that length there. So when we write an equation, we can say 2x is going to equal 17. Then we simply solve for x. Well, in this case, there's not much to do. You have 2 x's, but you only want 1, so we would divide both sides by 2. That would give us x equals 8.5, or 8 1/2. Is it possible for a variable to be a fraction or a decimal point? Of course it is. It's just a number, and that is the number that represents x in this case. Last example I'm going to work with you will show you how one of these secant formulas work. And again, it is up to us to decide what type of a formula actually works with this. Okay, so you would have to look at this problem and identify that it is two secants from a common endpoint. You would have to identify that the problem is talking about the lengths of those secants from that common endpoint. Okay, so this is the rule that says the length outside on one secant will multiply times that entire length of that secant, and that should equal the length outside on the other secant times the entire length of that secant. Okay, so let's see if we can't assemble a problem. Let's start off with the top secant. We want the length outside of the circle. So what would that be? Okay, 6 is the length outside the secant, and that should multiply times the length of the entire secant from the common endpoint all the way to the back side of the circle, and conveniently that was 10. Okay, so 6 needs to multiply by 10, and then that should equal the same process from the other secant. Okay, so on the other secant, what's the length outside the circle? That would be a 5. Okay, and then that should multiply by the length of the entire secant, which is marked as x. So there's our x. That's what we need to work out. So let's see what we have here. 6 times 10 on the left side, obviously that is 60. And that will equal 5 times x over on the right side. 5x. Now clearly we don't want 5 x's, we only want 1, so we would divide the entire problem by that 5. That would give us x on the right, and on the left, 60 divided by 5 is 12. And there's your answer. Okay. What I'd like you to do is I'd like you to copy down these next 2 examples, and let's see if we can give these a try. Okay, I'd like you to come to answers for both of these values for x and bring them with you to class, and then we'll go over them together in class and we'll see if you got them right. I will leave the video running for a few seconds so you can copy down your examples, but this will be the end of the audio. As always, I appreciate you getting time to do your notes, and I will see you in class.